Hey everybody, happy almost October. Today we're going to take a little bit of time away from, learning new content to talk a little bit about our upcoming possible Regents exam. Again, we're not entirely too sure just yet if there's going to be a Regents at the end of this year, but in the event that there is, I want to make sure that you guys are extra prepared for that Regents exam. So first and foremost, just a little bit about the chemistry Regents exam. It's broken up into two different parts. It's broken up into the multiple choice section, which is 50 questions. That's 50 multiple choice. And then we have a bunch of part two questions or short answer questions, if you will. And I believe there are 35 of those. That gives us a total raw score of 85 points. Each question is worth 1 point. And then there's definitely different curves, which we can talk about as we get a little bit closer to the Regents exam. Okay, so multiple choice, straightforward, right? A, B, C, D options, really great. Part two questions are a little bit different, and so I thought it would be beneficial today to take a little bit of time to talk about how do we answer those part two questions, okay? So I know that in biology, there's a lot of explain and writing a lot of paragraph answers. But for chemistry, we do try to keep it short and simple. I would say the maximum length of any answer that I've ever looked at for the Regents is about 2 sentences, sometimes 3, but very rarely, okay? Most answers can be answered in 1 word or a short phrase. And I will help you guys as we go through during each unit, look at some of the different practice problems for that unit and talk about how to answer those. So I'm going to go ahead, I'm going to dig right in here, and we're going to talk about some of the example problems from this unit, matter. Okay, so looking at this first question on your screen, okay, we're given a diagram, right, for the classification of matter, and it asks us which type of mixture, which type of substance, or explain in terms of, and let's go ahead and look at that then. So question 1 says, which type of mixture is represented by letter X? So again, we want to take a look and find and locate letter X, okay? And you'll notice that it goes from the matter to the mixtures side. And we see that mixtures is subdivided into homogeneous. And so what is our other type of mixture? And again, this is where I'm saying you don't need to write a lengthy sentence. All you have to write is just the 1 word, right? So this is heterogeneous. And also, if you're concerned about spelling like me, I am not great at spelling. But if you're concerned, the Regents usually says if we can understand what you are trying to say, then that's A-okay. All right. Number 2, which substance is represented by letter Z? Okay, so again, we locate letter Z, here it is. And now we take a look, right? We have matter to substance. Substances are broken down into elements and compounds. Okay, awesome. Okay, now taking a look here, we have question number 3. So it says, in terms of particle arrangement, now I do want to point out that with these explain questions, we tend to need a little bit more information, okay? So again, when you see this term explain, that's typically when we're going to have to be using more than 1 sentence, okay? So explain, and then there's these tricky words right here, in terms of particle arrangement, which means that in our answer, we have to talk about the way that the particles are arranged, okay? So in terms of particle arrangement, why NaClAQ is homogeneous, okay? So they want to know why NaClAQ, which if we think back to what we've learned, remember that AQ means that it is dissolved into water, okay? So we have something dissolved into water, sodium chloride. Why is that considered homogeneous? Now, again, this is in terms of particle arrangement, and so the verbiage here, the wording has to be very specific, and we must talk about how these particles are arranged. So when we think back to our lesson, we learned that homogeneous mixtures have an equal distribution of particles, okay? And so that term particles has to make it into the answer. So NaClAQ, okay, is homogeneous okay? Because it has an equal distribution of particles. Now notice that I've abbreviated things here. So when you guys are answering questions for me, or if I give you an assignment like this for my class, I don't mind abbreviations. But it is key to point out that on the Regents exam, please don't abbreviate anything. You have 3 hours to take the exam, so you have plenty of time to actually sit and write things out. All right, question number 4 asks, given a mixture of sand and water, state one process that can be used to separate the water from the sand. So how can we separate sand, right, which is a solid, from water, which is a liquid, okay? And notice that here we have state as our kind of buzzword, state something. So if you make a statement, it just has to be very short, okay, very brief. In fact, one word, okay? So what is the one way that we can separate the water from the sand? We can use filtration, okay? Awesome. Now taking a look down, we have a new prompt of questions. Okay, so we have question 5 here. So we are given here a paragraph reading and then a table followed by a question. So again, test taking tells me that, or at least for me, I prefer to read the question first and see what information I need before I go through and read the whole paragraph. So again, let's go ahead and read that question. So the question states, identify a process used to separate the components of natural gas. So again, I'm looking at how do I separate it? Again, identify, that's a buzzword, okay? So this identify, again, usually means that you can have a one-word answer. How are we gonna separate the components of natural gas? Now, we can go look at the reading. Let's take a minute and see if there's anything helpful in there. So natural gas is a mixture that includes butane, ethane, methane, and propane. Differences in boiling points can be used to separate the components of natural gas. So it tells us right here that the way that we're going to separate this is by boiling point, okay? So boiling point separation. Now, that's not enough information because that's not what the process is called. So we need to know from our content knowledge, what process do we use to separate by boiling point, okay? And so if we think back to our separation of mixtures, that is going to be distillation. Now, another way that we could have looked at this problem is we could have just separately looked at this table and looked at the information that's given to us. And you notice that they list out all of the different boiling points here. And since they have different boiling points, that might have also led you to this conclusion of boiling point separation. And again, as you are exposed to more and more Regents Part 2 problems, you will notice that there is definitely problems that give you really long readings that have no information that is beneficial to you. So as we start to do these more, you definitely want to look at every component and see, right, is there a hint of information here and do I need to read the paragraph? All right, awesome. Let's take a look at question number 6. Okay, and our last question for the practice. So here again, we have a problem, a reading, and a data table. So I always again start with the problem. So explain why atmosphere is classified as a mixture. So they want us to use our content knowledge about mixtures to explain why atmosphere is considered a mixture, okay? So notice here we're given our atmospheric concentration of CO2. So they're telling us how much CO2 is in the atmosphere in 1960, 1980, and in the year 2000. Okay, we also have some additional problem or information. So let's go ahead and take a look. So nitrogen and oxygen gas make up about 99% of our atmosphere. Other gases include argon, carbon dioxide, methane, ozone, hydrogen, etc. So the amount of carbon dioxide can vary. Data from the concentration is given here. So there's not too much information here without a general understanding of, I guess, mixtures and why something is classified as a mixture. But I want to think back to compounds, versus mixtures here, okay? And so with compounds, right, remember we said that there has to be a fixed proportion, meaning that every time I have, let's say, water, it's always made of 2 hydrogens and 1 oxygen. Mixtures do not have a fixed proportion, okay? And what does that mean? That means that if I have a mixture, again, that can vary in how much is present. So, for example, I know I used the salad when I was talking about my husband and I, when I was talking about mixtures, right? But I could make a Kool-Aid mixture of all varying concentrations, right? So let's say your parents or your guardians want to make a Kool-Aid mixture, one for you and one for your 2-year-old sibling. Now, I don't know about you, but my parents definitely used to water down my Kool-Aid as a kid because they didn't want to give me too much sugar. But as I got older, I was allowed to have more sugar. So my 2-year-old sibling might get, 1 spoonful of Kool-Aid, and I might get 3 spoonfuls of Kool-Aid, right? They are both the same mixture, but the proportions of water to the Kool-Aid mix vary, okay? And so when we're looking at why atmosphere is classified as a mixture, we are looking at this idea that the amount of CO2 in the atmosphere can vary. Excuse me. Okay, so it can vary. All right, so these are, sorry, excuse me. These are some example part 2 questions and how we go about kind of looking and answering at them. In class, we're going to look at some more part 2 questions for this unit, and we will go through those together.